Medicine is a science and an art. The knowledge of medicine is science. The practice of medicine is an art. Okay. So here, what you are doing is, you are taking huge amounts of knowledge base in your head. Okay, huge amounts. And that is going to be there inside. When you reach specific situations, specific information will make sense at that time. Me as a biochemistry teacher, in each and every step, the thing I want you to do is to understand what you are reading, why is it clinically relevant. Okay? প্রত্যেকটা জায়গায়, প্রত্যেকটা পয়েন্টে, প্রত্যেকটা টপিকে সবার আগে ভাববে এটা কেন দেয়া হয়েছে, কি এমন খেয়ে দেওয়া দরকার ছিল, দরকার আছে। ওকে, কখন দরকারটা বোঝা যাবে, যখন পুরো জিনিসটা একসাথে হয়ে পুরো গোলটা কমপ্লিট হবে, then everything will make sense. Before that, it is not supposed to make sense. For God's sake, don't give up. ঠিক আছে? এই ফার্স্ট ইয়ারের 3টে সাবজেক্ট যেই মাত্র ছেড়ে দেবে, খেই হারিয়ে যাবে। যেই মাত্র খেই হারিয়ে যাবে, শুরুটাই করতে পারবে না। কোথা থেকে শুরু করব সেটা বুঝতে পারবে না। বুঝা গেল? যেইটুকুনি জিনিস পড়ানো হয়েছে, সেইটুকুনি জিনিস বাড়িতে গিয়ে একবার চোখে দেখতে, ইট টেক্স 1 hour মোস্ট, মেরে কেটে ওই 1 ঘন্টা ইনভেস্ট করো, otherwise it will not make sense. Okay, so you have learned about cells, organelles, ... You have studied carbohydrate chemistry, yes or no? You have studied carbohydrate chemistry, yes or no? পড়ানো হয়েছে তো? Stereoisomers of glucose, types of glucose, okay, types of carbohydrates, classification of carbohydrates, এগুলো পড়ানো হয়েছে তো? So today we are going to take up a very important topic, that is amino acids. Okay, so I have to tell you what are the competencies of this chapter. What do you need to know of this chapter in order to feel competent? Okay, first thing is you need to know what is an amino acid, what is its basic structure, how do we classify it, and how are they clinically relevant. If you can answer these 4 questions after the end of this lecture, you can consider yourself competent. Okay, then you can say you are competent. So I think many of these things have been already covered in your class 12, right? So can you tell me, in order to be an amino acid, what is the cardinal requirements? কি কি থাকলে তুমি বলতে পারবে ও হচ্ছে অ্যামাইনো অ্যাসিড, ফ্যাট নয়? বল বল। কার্বক্সিলিক অ্যাসিডের একটা গ্রুপ থাকবে, ভেরি গুড। হ্যাঁ, একটা অ্যামাইনো গ্রুপ থাকবে, আর হাইড্রোজেন, তো হাইড্রোজেনের জায়গায় অ্যালকাইল গ্রুপ থাকতে পারে, অ্যারোমেটিক গ্রুপ থাকতে পারে, এস্টার গ্রুপ থাকতে পারে। কাজের সাথে লেগে আছে এই দুটো কার্ডিনাল জিনিস। কি কার্বন? ইটস অ্যান আলফা কাইরাল কার্বন। It's an alpha chiral carbon. What do you mean by an alpha chiral carbon?
Alpha carbon চারটে আলাদা জিনিস থাকে।
Yes, that is what is known as a chiral carbon. How does it become beta to alpha? No, it's the amino group. It is the amino group. If the amino group is in direct bond with the alpha, with the chiral carbon, then it is an alpha chiral carbon. If not, it is not an alpha chiral carbon. But alpha chiral carbon is not the definition. Because you will find amino acids.
I have a call emergency.
You will find compounds which are non-alpha. That means the amino acid, the amine group of the amino acid will not always be attached to your chiral carbon in order to be an amino acid. Okay. So what is so special about it? What is so special about it? Let's look at the structure a little bit, right? This is your carbon. This is your NH3 plus. This is your COO minus. This is your H. This is your R. This is the basic definition. What is the speciality of this thing? Why is it so relevant? Very good. It's a monomer of polypeptides. Very good. But I am not talking about that. I am talking about why body has selected this one to be a building block. Very good. It can remain in a zwitter ion form or an ampholyte form. Ampholyte. Zwitter ions are also called as ampholytes. So what do you mean by zwitter ions? Let's simplify things.
Acid and base both react করতে পারে এটা।
Both react করতে পারে। Speciality টা কি? Electron cloud is being shared. The electron cloud is being shared. If you put it in an acidic medium, suppose we put it in an acidic medium, H plus. What will happen? This will go to very good. এটা গিয়ে এই জায়গাটা থেকে একটা অক্সিজেন তুলে নেবে। তাহলে এখানে যে অ্যাক্টিভ ফর্মটা তুমি পাচ্ছ সেটা হচ্ছে CO মাইনাস এই জায়গাটায় ইলেকট্রন ক্লাউডটা শেয়ার হচ্ছে। That is why it is stable. That is the first cardinal point. Amino acids are stable due to the sharing of electron cloud from amino terminal to the carboxy terminal. Plus, this particular carbon, this particular alpha chiral carbon gives it a lot of rotational mobility. It gives it a lot of rotational mobility. And this rotational mobility gives you configurational stability. It will give you conformational stability. Because at the end of the day, these amino acids will overlap among each other to produce a protein. Right? যখন ওই প্রোটিনটা তৈরি হবে, it needs to be in a stable configuration. Due to the presence of this alpha chiral carbon, it can be blended in many places. And henceforth, it gives you conformational stability. Everything alright?
আমি অ্যামাজন
এটা কি ইমার্জেন্সি ফোন বলে চালিয়ে দিবি? বদমাইশ নয়, ভেতরে কান ধরে কাট করে দাও।
আমার ট্যাপটা আসছে।
So, general structure of amino acids. Same thing, যেটা বললাম. Plus, this amino acid has the capacity to form peptide linkage. That is CONH linkage. water will go.
Water.
Water will go. Two amino acids are interacting among each other. The water will go, and the resultant bond will be CONH. যার দুদিকে দুটো C আছে। Now again, an electrophilic group just together with a nucleophilic group. Electron sharing, stable bond, partial double bond structure. Partial double bond structure. Very difficult to break. Very difficult to break. That is why when you will be taught proteins, you will see that the backbone is always made up of peptide linkages because they are so stable. Okay, so these are the two cardinal features, structure of an amino acid: deuteramine formation and amide linkage. Okay, very good. Now, we human beings have a tendency to classify everything. We human beings, we have a tendency to classify everything. And sometimes even one classification is not sufficient to quench our thirst. You remember taxonomy?
Yes.
You remember periodic table? Man, those are horrible days. Okay? Those are horrible days. Don't worry, things are going to be more horrible. Okay? So here, for classification also we have different types of classification. As if one was not enough. So, different types of classification you have to remember 4. First is standard amino acids, non-standard amino acids. That is the first base of classification. Okay. The second is essential amino acids and non-essential amino acids. Okay. Third is on the basis of polarity. Hydrophobic amino acids, hydrophilic amino acids. Okay. Hydrophobic amino acids and hydrophilic amino acids. Then comes your glucogenic amino acids and ketogenic amino acids. And finally, the large one on the basis of their structure. On the basis of their structure. Most common mistake in writing classification of amino acids. Students have a tendency to write only one classification, where there are 4 classifications. You do that, you are going to miss marks for 3. Okay? You are going to miss marks for 3. So that is not supposed to happen. Okay. Introduction I have already told. Amino acids are the building units of proteins, and proteins are the essence of life. Going on forward. See, here we have a particular terminology. You are quite known to it. It's called gene expression. Gene expression. Can you tell me what do you know about gene expression? Does your gene express yourself? Does your gene talk to you? No, why not? Of course genes talk to you. Your genes don't talk to you. Bicha, that happens. Okay. So what do you mean by gene expression? Can anyone tell me?
It's about making protein.
Yes. From gene you have mRNA. From mRNA you have protein. Gene to mRNA transcription. mRNA to protein translation. Now this poor soul, the formation of the CONH bond or peptide linkage is basically happening inside a ribosome. There are 2 sites, one amino acid site, one peptidyl site, and it was carried to the particular mRNA via tRNA, global leaf Below there was the triplet codon. On up in one hand, it is clutching the amino acid. This is one tRNA. This is another tRNA. Got hold of both amino acids. What happened? Which enzyme? Peptidase transferase. Formation of CONH bond. And that is the central dogma. That is the central dogma for the basis of life. Now look there. Genetic code specifies 20 L-alpha amino acid. What is this enzyme? Capital L or small l? Livolotidity কি থাকতো? Minus sign থাকতো. So this is L configuration, that is ammonia and ammonia group on the right side. All biological active amino acids are of L configuration. Okay? The human body does not have the capacity to digest, formulate or utilize the amino acids. Okay? That is why here we have L-alpha amino acids. That is why we have L-alpha amino acid. So that basically the central dogma is written there, nothing else. It's just the central dogma. কেন এটা পড়ালাম? এই কথাগুলো এই জন্য বললাম because you will utilize that concept in the first classification, that is common amino acids and uncommon amino acids. Okay, common amino acids and uncommon amino acids. So what do you mean by common amino acids? General structure R NH3COH. Please don't write, take the PDF. Listen to me. লিখে শেষ করতে পারবে না? Listen to the lecture. Take something home. মাথায় রাখো, খাতা নয়, ওই খাতাটা জীবনে খোলা হবে না। আমার মতো স্টুডিয়াস হলেও খোলেনি, তোমরা 1000 বার খুলবে না, কোনোভাবেই খুলবে না। ঠিক আছে? So take it inside your head. This PDF I will give it to you. প্রিন্ট আউট করে রেখে দেবে, ফাইলে রেখে দেবে, রাতে গিয়ে একবার পড়ে নেবে, ইম্পর্টেন্ট জায়গাগুলো আন্ডারলাইন করে নেবে। পরে যখন ওখানে ফিরে আসবে, you will not feel lost. বুঝে গেছে? Okay. So, side chain determines protein folding, binding to specific ligand, interaction with its environment. Side chain, it is meaning this group R. This R will give rise to all the properties that an amino acid may exhibit. Anyone got confused or lost till now? Raise your hand. No one? Everyone is getting? কোথাও কোনো সমস্যা নেই, কোথাও কিছু বোঝার মিস্টেক হয়নি? All of you are with me? Very good. So this R group will determine whether this is going to be a hydrophilic amino acid, whether it's going to be a hydrophobic amino acid, whether it will be a basic amino acid, whether it will be an acidic amino acid, whether this amino acid is going to be a oxygen carrier molecule, or whether this amino acid is going to be a structural unit, whether it's going to be a part of an enzyme, is it going to be a part of a channel? All the magic will reside in the R group. Okay, all the magic will go inside the R group. So this is all about common amino acids. So there must be an uncommon amino acid as well, right? So let's have a look at the uncommon amino acids. So non-standard amino acids can be of two types. Okay, the first type is selenocysteine and pyrrolysine. Selenocysteine and pyrrolysine. What is different? Can you name the 3 stop codons?
Yes, sir.
Please do. AUG is start codon, methionine. Stop codon. UAA UAG, UGA. What is the codon over there? UGA. UGA. What is it doing? No, it's not a stop codon. No, it's not a stop codon. For this specific gene, you have, no, it's not a start codon. You have a specific portion of the which ensures the attachment of selenocysteine in the amino group chain. Okay, that is why here, in case of this SES, selenocysteine insertion sequence, UGA, in place of working as a stop codon, will put a selenocysteine molecule in the amino acid chain. And that's why it is an abnormal amino acid. Similarly, in pyrrolysine, it is found in, see it's written, methanogenic archaea. Methanogenic archaea, such a difficult word. Mane ki? Methane tori kora bacteria. Okay? Simply speaking, it is methane tori kora bacteria. Methanogenic archaea. ঠিক আছে? Jargons. Don't get lost to jargons. Have the concept clear, know meaning of every word, and you will sail through, you will never fumble. Do not get lost in jargons. If you are using a word, make sure you know the meaning of it and you know the proper way of utilizing that word. You will never be wrong. Okay? So, first is selenocysteine, because here due to the SES segment, selenocysteine is being incorporated into the amino acid chain by UGA, which is supposed to be a stop codon. And here, what is happening is, here UAG is adding pyrrolysine. Should have been a stop codon. This is why biology is so diverse. So this is definitely an abnormal amino acid. What are the other abnormal amino acids? Intermediates in metabolism, which will not be there for a long time. Citrulline, ornithine in urea cycle. Citrulline and ornithine in urea cycle. They are only present when the metabolic pathway is active. It will not be there continuously. So that is the second type of non-standard amino acid. Second classification of amino acids. Non-protein amino acids, non-alpha amino acids, modified protein amino acids. Non-protein amino acid means very easy. Non-protein, not being utilized in protein generation. Not being utilized in protein generation. See, ornithine and citrulline, intermediates of urea biosynthesis. Not being utilized in protein generation. Non-alpha amino acids means it's not an alpha carbon. The amino acid is not attached to the alpha carbon. It is attached to the secondary carbon. An example is GABA and beta alanine. GABA, full form? Very good. It is basically a neurotransmitter. It is basically a neurotransmitter. What does it do? Slows down nerve conduction, especially in case of neurogenic pathways and pain pathways. Anyone has a patient of cervical spondylosis or lumbar spondylosis at home? Disc prolapse patient at home? Yes, you do. They have shooting pains, right? What to do? GABA. Okay. Pregabalin, neurokine G, gabapentin. Okay. Same thing. You are utilizing it to slow the painful nerve conduction. So the latency is increased and the pain is decreased. Okay? Is it relevant? ডাক্তারি পড়তে এসেছিলাম কি পড়াচ্ছে অ্যামাইনো অ্যাসিড প্রোটিন ফ্যাট কি পড়াচ্ছে ভাই ডাক্তারিতে তো আমি যাই জানি প্রশ্ন জিজ্ঞেস করব শুনবো ওষুধ লিখে দেবো ফার্স্ট ইয়ার ফার্স্ট জানতে হবে
স্যার প্রিগাবা এন্টিটা কি এটা থেকে?
হ্যাঁ প্রিগাবালিন তো গাবাপেন্টিন তো
ও ওটা খাওয়ানো।
ও গাবাই তো তৈরি করছে ওটা গাবার প্রিকারসার
আচ্ছা
ঠিক আছে যেরকম পার্কিনসনিজমে আমরা কি দিই ডোপামিন অ্যাগনিস্ট দিই ঠিক আছে ডোপামিন অ্যাগনিস্ট দিই তারা কি করছে শরীরে গিয়ে ডোপামিন তৈরি করছে বিকজ দ্য বডি ইজ ডেফিশিয়েন্ট the body is deficient and that is why the patient is having oral tics. These are called rabbit tics. They will have a masked face. They will not have any expression. They will walk like this, testing at gate. All the magic is there in neurotransmitters. And neurotransmitters where? Are neurotransmitters are what? Proteins. So if you don't know protein, you can't know neurotransmitters. If you don't know neurotransmitters, then you cannot identify. If you cannot identify, if you do not have a basis of curing a patient, you will not be able to cure a patient. That is why this is relevant. That is why this is relevant. Okay? So, these are the other qualifications. Now the most important portion. Most important portion. Amino acid based on nutritional requirement. Will be asked in Viva, will be asked in slides, will be asked in 3-number short notes, will be asked in postgraduate entrance test, will be asked in your DM entrance exam. You are not one of you. Okay? Have to remember. Classification in basis of nutrition. Very good. Very easy. Very easy. Essential amino acids. What do you mean by essential amino acid? Why will it be essential? Because body cannot produce. If the body cannot produce, then you must outsource.
yes
And what is the outsourcing material? Food. Food. What is your favorite food? Chicken and mutton. Uncooked. Okay. So very good. Food. So essential amino acids are basically amino acids which has to be supplied by diet because they are not synthesized in our body. Easy peasy, chicken cheesy. Food, chicken. Okay. So next one. Non-essential. You can synthesize. You don't bother. You can synthesize it so you don't bother. You have what? How do you synthesize amino acids? Transamination. You transfer one alpha amide group to one keto acid to form the correspondingly needed amino acid. And that is how you have only 7 essential amino acids. Rest you can just make because you have the enzymes. Okay. And finally here also there is a catch. Semi-essential amino acids. Semi-essential amino acid. What do you mean by semi-essential amino acids?
The body can synthesize but in very less.
Nah. When you are a child, you had the ability to synthesize. Now you have given food, you don't have it. You have to take it through food. Okay. The utility of the brain was very good. In most of the cases, the answer should have been, it can be produced in the body, but not in that significant amounts where it is needed, so you need a nutritional supplement. No, that's not the answer. The answer is when in children, they can produce selenocysteine. Once you start giving vote to Didi and Modi, that privilege is gone. Okay? Don't think for once if you even give vote at Nota, then you will be able to synthesize selenocysteine. No. What's gone is gone. Gone. Leave it. Have it through food. Seleno cysteine একটা অ্যামিনো অ্যাসিড ব্যাকটার আছে COO minus alpha carbon NH3 এখানে আছে R এই R টাকে তুমি যদি রিপ্লেস করো CH3OH দিয়ে you will find a hydroxy amino acid so in place of R you put a CH3CHOH this is what alcohol okay if you remove this O and put SH it is thiol selenocysteine is nothing but a selenium adjunct amino acid of cysteine and cysteine is nothing but NH3 plus CO minus C CH3 CH SH in place of OH I will show you it's there in the lecture not to worry okay this is the most important part you got to mug it up you got to commit to memory and vomit to paper how there is a mnemonic and the mnemonic is a hill PMT TV a hill PMT TV a hill PMT TV PMT আগে নাম ছিল নিটের আগে নাম ছিল PMT yes PMT এটা নিটের আগে A for arginine H for histidine I for isoleucine L for leucine lysine P for phenylalanine M for methionine T for threonine T for tyrosine and V for valine will appear in any and every exam cannot get rid of it you cannot get rid of it okay so a hill PMT remember this you are safe okay remember this you are safe very good another thing very common question often appears as short note one day one fine morning this amino acid will be metabolized okay one day it will be metabolized it will be of no use so it will be metabolized what will be the first step remove the NH2 group that is called oxidative deamination that is called oxidative deamination what are you left with after removing the amine group alpha keto acid okay what will you do with this alpha keto acid
Oxidate.
yes you will channel it into where Krebs cycle or glycolysis because you actually want to utilize this backbone for energy production okay on the basis of this metabolism amino acids were classified into three classes ketogenic amino acids those amino acids which will directly produce acetyl CoA or acetoacetyl CoA on metabolism okay ketogenic amino acids the second is glucogenic amino acids what do you mean by glucogenic amino acids it means it will form intermediates of either glycolysis or Krebs cycle That is glucogenic amino acid. So you can utilize it for gluconeogenesis and make glucose out of that. Clear? Clear? And the other is both. Na 50-50. Pyar ka wada 50-50. এদিকেও আছে ওদিকেও আছে মামার ঘরে ঠিক আছে নাও very easy to remember first always write ketogenic amino acids. Ketogenic amino acids are basically branch chain amino acids and those two branch chain amino acids are lysine and leucine over. These are purely ketogenic amino acids. What about glucogenic amino acids? Remember the two basic amino acids, histidine and arginine. Rest all are both. খুব সোজা না সবার আগে মনে রাখবে কিটোজেনিক কিটোজেনিকের দুটো লিউসিন লাইসিন ব্রাঞ্চ চেইন অ্যামাইনো অ্যাসিড তারপর হচ্ছে গ্লুকোজেনিক হচ্ছে আর্জিনিন হিস্টিডিন হয়ে গেল বাদ বাকি সব না 50-50 ওকে মনে রাখা যাবে ইজি টু রিমেম্বার ভেরি ইজি টু রিমেম্বার চলো this is the main thing. This is how amino acids are classified on the basis of their structure. Okay, so you have got a hydrophobic amino acid, you have got a hydrophilic amino acid. Can you tell me why does this hydrophobicity and hydrophilicity exist? A polar group, non-polar group, why? I am looking for the concept of magnetic dipoles. এবারে ডাইপোল তো ক্রিয়েট হয়েই আছে তো সবারই তো হাইড্রোফিলিক হওয়া উচিত ছিল তাই না ডাইপোল ক্রিয়েট হওয়া নেই NH3+CO- দুদিকে দুটো ডাইপোল হ্যাঁ ভেরি গুড ওই এক্সট্রা আরেকটা গ্রুপ ডিটারমাইন করবে
সেটা তো স্যার অ্যাসিডিক বেসিকের ডিটারমাইন
হ্যাঁ না অ্যাসিডিক বেসিক মানে কি একটা পজিটিভ চার্জ আছে একটা নেগেটিভ চার্জ আছে তারপরেই হাত লাগাও পজিটিভ নেগেটিভে যেই মাত্র এইদিকে যদি পজিটিভ নেগেটিভ তোমার চার্জ হয় তোমার ম্যাগনেটিক ফিল্ড এইদিকে তৈরি হবে ম্যাগনেটিক ডাইপোল হলো ম্যাগনেটিক ডাইপোল হলেই একমাত্র জলে গুলতে পারবে তাই না মনে আছে হাত লাগিয়েছো তো পরীক্ষার সময় যারা লাগায়নি তারা এই জায়গায় বসে নি সবাই লাগিয়েছে ঠিক আছে তা একই জিনিস what do you mean by hydrophobicity বা hydrophilicity means water generates a dipole. What is a dipole? Partial excess of oxygen cloud on one side and partial basic nature on another side that causes a fine electric current streaming. এই ইলেকট্রিক কারেন্ট স্ট্রিমিংটার জন্য একটা ম্যাগনেটিক ডাইপোল তৈরি হয় আর অল ওয়াটার মলিকিউলস আর ডাইপোলস ইউ নো দ্যাট ভেরি ওয়েল তাই না দিস ইজ দ্য বেসিস অফ হাইড্রোফোবিসিটি এন্ড হাইড্রোফিলিসিটি বুঝা গেছে দিস ইজ দ্য বেসিস অফ হাইড্রোফোবিসিটি এন্ড ফিলিসিটি তাহলে ভাই এখানে এই যে আর গ্রুপটা আছে CH3 আর NH2 তো দুদিকে আছেই তাহলে সবারই হাইড্রোফিলিক হওয়া উচিত ছিল কিন্তু সেটা হচ্ছে না কেন হচ্ছে না ডিউ টু দ্য আর গ্রুপ okay due to the R group so here the champion is the R group okay so what can be this R group it can be a polar R group it can be a non-polar R group ঠিক আছে polar R group non-polar R group polar R group এ কি কি আছে alkyl what do you mean by alkyl
CH2CH3
it's a carbon
hydrocarbon
it's a carbon chain chupta okay and the second is aromatic what do you mean by aromatic benzene ring or any ring structure why is it non-polar benzene ring ই থাকবে ওটার জায়গায় যদি একটা হাইড্রক্সি দিয়ে ফেনল করে দাও তাহলে সেটা আর থাকলো না হাইড্রোফিলিক হয়ে গেল হাইড্রোফোবিক আর থাকলো না বোঝা গেল till now you are still with me no confusion till now very good now what about polar neutral What neutral? Electrically neutral. Electrically neutral. Electrical neutrality does not always correspond to non-polarity. Why? Phenol is electrically neutral, tyrosine. Phenol is electrically neutral. Will it not be polar? It will not be polar because it is electrically neutral. একদিকে NH3COH ব্যালেন্স করে দিয়েছে আর R এর যে অ্যারোমেটিক গ্রুপটা আছে that is electrolytically stable, that is why it is polar. ডাইপোল তো তৈরি হচ্ছে অক্সিজেন এটা তো ঘুরছে, ইলেকট্রন ক্লাউডটা তো ঘুরছে এক জায়গা থেকে নেই, রেজোনেন্স মডেল কখনো পজিটিভ হচ্ছে কখনো নেগেটিভ হচ্ছে, কখনো ওর উপরে মাইনাস যাচ্ছে কখনো ওর উপরে ডবল বন্ড দিয়ে স্টেবল হচ্ছে তো তাহলে ক্যান ইট বি নন পোলার? It can never be non-polar. It will always be polar. Okay, very good. So non-polar is alkyl group and aromatic group. Similarly, polar will be neutral and it will be acidic or basic. It will be acidic or basic. পরিষ্কার, ঝরঝরে পরিষ্কার কনসেপ্ট। কারোর কোথাও কোনো জায়গায় বোঝার সমস্যা হলে বলো। Till now, you have any doubts? No. Very good. Here, I will discuss amino acids and how they actually look like. Under no circumstances, we are expecting structures out of it. Okay? We are not expecting structures out of you. It is not possible for you to study 3 subjects at one time and then draw structures. That is impossible. We are not expecting structures. We are only expecting the names. Why are the structures important? Because I can show you. See, the first is the basic, most common amino acid, and that is glycine. In glycine, you see the R is being replaced by an H. That is your glycine. Then you have alanine. In alanine, what do you have?
CH2.
You have a CH3 in place of an H. Now you have got valine, leucine, isoleucine. All of them are branch chain amino acids. See, all of them are branch chain amino acids. Here, consider this. One, this is a branch. Consider this one, this is a branch. Consider this one, this is a branch. Okay? Very important. Marble syrup urine disease. Branch chain amino acid urea. Absence of dehydrogenase enzyme will cause marble syrup urine disease, in which the baby will be born with short kidneys. Okay? And the urine will have a typical burnt sugary flavor. Ever made caramel at your home? Try to burn sugar sometime. That typical smell you will find in maple syrup urine diseases. Okay? That is why this is important. Maple syrup urine disease, MSUD. All will be dealt later also. No worries. Each and every deficiency disorder that I will tell you, they will be taught to you again and again. As of for now, I just want you to be familiar with the names. Okay? So valine, leucine, isoleucine, branch chain, hydrophobic amino acid. Okay? Clear. Very good. See, now you have serine, threonine and tyrosine. They have an OH group attached to them in the R. In place of R, they have a OH group attached to them. See. This is our CH3OH. This is our CH2CHOH anomide. And in case of tyrosine, what you will find? In place of this, you just have a phenol. Think of this. I will remove it, I will write an H, and here you have a phenol group. becomes tyrosine. Simple? Simple or not? Not confusing at all? 5 দিন পরে বুঝতে পারবে কতটা কনফিউজিং। Not right now. As of right now, you are Akuna Matata. No assets. Okay? Wait. Okay. Then we have aspartate, aspargine, glutamic acid, glutamine. These are dicarboxylic amino acids. Aspargine, glutamate, glutamine. Dicarboxylic amino acid. Meaning, very good. It has got 2 carboxyl groups attached to it. Very good. Palash. Adenine, lysine, histidine. Dibasic amino acids. এটা ডাইকার্বক্সিলিক ছিল দুখানে NH3 গ্রুপ আছে একটা আলফা কার্ডিয়ালের সাথে আরেকটা ফ্রি ওকে and these are so important they give you the buffering action of blood they give you the buffering action of blood okay that is how ketoacidosis patients are able to survive because this second amide group will take up the excess hydrogen and neutralize so that your blood pH is constant. Okay? So that your blood pH is constant. Phenylalanine, benzene ring attached to alpha carbon, tyrosine, phenol ring, and tryptophan, heterocyclic ring. Heterocyclic ring. Okay, and this ring is also known as indole ring. This ring is also known as indole ring. These 3 are utterly important amino acids. They are precursors of different neurogenic substances being produced in your brain. Okay? Finally, proline. Okay, finally there is proline. This proline is very important because it is an important part of collagen. It is an important part of collagen. And due to this heterocyclic appearance of proline, it can fit in very small places and give structural rigidity for your supporting proteins. Okay? What is collagen? What does it do? It's a shock absorber. It's a shock absorber. How it is functioning as a shock absorber? Because the proline in the loops and bends give it an elastic appearance, which increases the tensile strength. Okay? That is why proline and hydroxychloroquine are so important. Finally, a few functions of essential amino acids. Once you take the list, do learn different amino acids are precursor to all different things because we are out of time. The second class will start. Okay? Take it from me. Okay? Someone take it from me. Give it a reading. If you have any problems in next class, you are welcome to ask questions. Till now, everybody has understood the concepts. You know what is expected out of you. You know what is expected out of you. You know what are the things that will be asked from this chapter. Clear? Have a good read. I do not think you will have any point of confusion. Okay? If you have a point of confusion in next theory class, do ask. Okay? That will be all for today.
So what is this thing? Hemoglobin? In the class 2 level, what is this thing? What is hemoglobin? Protein molecule, at least we know this thing. Protein molecule with iron. So the basic structure is, although we do not need the structure in detail, that is a part of chemistry, but at least for physiology and medicine purpose, we do not need to know the detailed structure. So just the basic structure, what is it made of? Iron and protein. This is heme, that means heme plus globin. There is a heme molecule. So this is basic. So here we will tell that, have you heard this term in chemistry? Chemistry will know far better than this. Yes. I last did chemistry 19, 20 years ago, 18 years ago. So inorganic, organic, every aspect of chemistry you go better than me. So I am having to go through books and materials for what group stands for what and how many carbon atoms, how many. Although we don't need the detailed structure here, still we need to know that hemoglobin is something there is called the. So what we said that basics, just the basic thing we have to know that this is porphyrin rings are present in this structure of hemoglobin. So porphyrin ring is what? Tetramer of this pyrrole. So pyrrole is, you may have heard, you may not. Pyrrole is basic. It contains 4 carbon atoms, 5 hydrogen atoms, and of course 1 nitrogen. So this arrangement, the arrangement of this carbon, nitrogen and hydrogen atoms will decide what type of ring is that, but there will be, the thing is, this pyrrole structure, porphyrin will be formed by a tetramer of this pyrrole structure. Tetramer means 4 units, monomer means 1 single unit, and multiple units, polymer. So polymer may be 2, 3, 4, anything. Tetramer is when there are 4 units. So at the center of that, so if that is the porphyrin ring, so basically we can write this as, there will be nitrogen in the middle, where nothing is written, there is carbon, there may not be carbon, or there may be double bonds. So all these things you know better than me now, at least for the time being. Or there will be carbon atoms. Okay. So for simplifying, at these positions we write what are these? M stands for methyl, V for vinyl, P for propyl. So some or other of the group, all cannot be present together. So either of these will be present. So depending on what is present, the structure is determined. Okay. So we will come to the variants of the different types of hemoglobin in the further discussion, but at least this will be the thing that there will be a nitrogen atom and there will be several carbon atoms. Usually how many? 4. 4 carbon atoms, 5 hydrogen atoms. Methyl group is easy. Methyl group is the simplest, CH3. Like vinyl group is CH, CH2. Like this, it will be present. Okay. So on all 4 sides, there will be similar groups, and in the middle, what will be there? Iron. if the usual structure of hemoglobin, it will be ferrous form. Well, actually, when it gets converted to the ferric form, it loses the capacity. What is the function of hemoglobin? Primary function we know. Main function of hemoglobin is to transport oxygen to tissues. That means from lungs, if oxygen is transported to tissues, and from tissues, what will come back? Carbon dioxide. So this is the main primary function. Actually, this is the function. Oxygenation, deoxygenation. This is almost the only function of all the other functions which we relate to hemoglobin are all based on oxygenation and deoxygenation of hemoglobin. Now, if this ferrous form is converted to ferric form, hemoglobin loses its capacity to carry oxygen. So that is the importance of this maintenance of this ferrous form. And now this will be linked to nitrogen, the porphyrin ring, that structure will be complete. Detailed chemistry structure we don't have to know, we just have to know. We name an important molecule, just an important molecule in biology, not in human beings, in biology, which has a similar structure.
Chlorophyll.
Very good, chlorophyll. Chlorophyll is required for photosynthesis in plants. That is one of the important, means very, very important process that is going on in this biological world, that is photosynthesis. So chlorophyll, instead of this, there is magnesium. Okay. Now the structure, the pyrrole rings may be somewhat differing in structure from case to case. Actually, different variants of hemoglobin will have different types of these pyrrole rings. But the basic structure is the iron will be, that is the ferrous iron will be linked to these pyrrole structures forming the protoporphyrin ring, that is the tetramer of the pyrrole ring. Okay. And the synthesis of hemoglobin, where does it occur?
Red bone.
In the red bone marrow. Now, every hour, some hemoglobin is being destroyed and some hemoglobin is being formed. Usually it's 0.3 grams every hour. Whatever is destroyed, it is also synthesized. So, this thing usually hemoglobin is, whatever is synthesized, that is degraded. Same thing, 0.3 grams every hour synthesized, and also 0.3 same is degraded. So unless there is some other deformity, any metabolic deformity or anything else, the degradation overcomes this synthesis, there should not be any deficiency. But if there is iron is not sufficient, then what will happen? Then synthesis cannot match degradation, and then there will be anemia. That is iron deficiency anemia. Anemia we will read about it. In hematology itself, anemia we have to read in detail, first in physiology and then in medicine. But what is the commonest type of deficiency in our country? Because here, after entering the MBBS course, we should relate ourselves to what is happening in our, because most of us as doctors will work in our country itself. So, in our country, what is the commonest type of anemia? Anemia is the, we read about anemia is the decrease in production of, or decrease in RBCs, not only production, I'm sorry. Production is one of the things by which anemia can occur, one of the ways, but decrease in RBC or hemoglobin or both. Okay, decreasing by how much? Everything will read, but decreasing RBC or hemoglobin or both. What is the commonest type of anemia? It is nutritional anemia. Nutritional means iron is deficient in the nutrition. So iron deficiency anemia is occurring. We say nutritional anemia because iron mainly comes from the food. So nutritional anemia or iron deficiency anemia is the commonest type of anemia in our country. So that is due to hemoglobin is not being able to synthesize. So how much it will be synthesized? 0.3 grams every hour will be synthesized, and similar amount will be degraded. Then only the balance the amount will be maintained. So it occurs in the red bone marrow. What is the content of hemoglobin in the human blood? 60 grams. Whenever we have entered, now we have entered a graduation course. Whenever we will mention some content, something, we will mention a range. This is from the first day itself. Anything. Like, just one simple example, in the school days we used to say human pulse rate is 72 per minute. Yes or no? Yes. Since childhood we have learned, okay, human pulse rate, this is the pulse, this is 72 per minute. Here we will not say like that. 72, our exact figure, we all know that these things in biology, physiology, human physiology, in these science, nothing is, this is not, everything is approximate. That is, there is a range. Everything is approximate. It cannot be exactly 72 for everyone. So we have to say it is between 60 to 100. Okay. Usual normal pulse rate is between 60 to 100. Everything we have to say a range. So we cannot utter like that hemoglobin is 16, 14, 15, 10, 12. No. So we have to say a range. We usually say it is. So the authors vary. So 14 to 16 grams, but in how much of blood? Per 100 ml. Per 100 ml of blood. Usually do not write 100 ml, it's deciliter. That is 100 ml is DL, liter, then deciliter, centiliter, milliliter. So 100 ml is DL. So you can say for 100 ml, but most standard authors write like this. 100 ml and DL is the same thing, 14 to 16 gram of DL of blood. Now, due to some causes which we read in physiology itself, in males it is somewhat more. So, in some authors write that in males it is around 60, in females it is around 40. In females it is around 40. So that's why I write it's 14 to 60. Now it varies according to the this country, race, origin, everything, some amount varies. In India, when you will treat patients, even if you get in females 10 to 11, it is sufficient that you will not call it, that means you don't need to treat for anemia. So by definition, 11 should be anemia. Okay, 10, 11 should be anemia. Actually it is. Foreign authors are writing 10, 11 gram per deciliter of hemoglobin if you get it's anemia. But India we usually do not put it. Because here 10 to 12 gram per deciliter of blood hemoglobin is we do not call it, we have to by definition call it anemia, but usually we are not worried. Okay. So this is how we express, this is the range 14 to 16 gram per deciliter of blood. So from this you can calculate what is the total amount of hemoglobin in the body. It should be easy. So 1 deciliter of blood contains say 15. 1 deciliter contains 15 grams. This is blood. Now we know what is the human blood volume? 5 liter. Roughly 5 liter. 5 to 6 liters it is. So from here you have to convert here 5 to 6 liters is 1 deciliter. If it is 50 gram in 1 liter, it is liter is how many times of deciliter? 10 times. Right? 10 times. So it will be 150 gram. So in 5 to 6 liters it will be. So this is the total amount of hemoglobin. Out of that, 0.3 grams, and that is every hour. Whenever we express something, we have to mention the units correctly. Okay. During the exam, what happens? We tend to forget the units, or here, what in MBBS course, not only MBBS, all through medical life we will get. So not only we have to appear for the theoretical exams, that means written exams. Lot of viva exams. In fact, there will be some cases where there will be no theoretical exam, but there will be a viva exam. Not in the MBBS course, but later. So we have to prepare for viva. During viva, maybe we know a lot. Sometimes it happens we know a lot, but we just can't express ourselves. So out of that, the exam fear or something, exam phobia. So we know the correct thing. So simply in case of hemoglobin, we are saying 14 to 16, but forgetting the unit. So we should remember this. We should remember from the first day itself that we have to express in the correct unit. Every time you mention a number, you have to express the correct unit. So what is the content of hemoglobin in blood? We usually express it as per deciliter or per 100 ml or per dl. 14 to 16 per dl or 14 to 16 per 100 ml. Now from that it is easy to find out what is the total content of hemoglobin in the body. It is 900 grams. So in foreign authors books you will see it is given 900 grams because they are taking it as 6 liters. So we take it as 5 to 6 liters and say it's 750 to 900 grams. So in this context we say another thing that any book you may follow for every subject, for any subject, you may like to choose the book you follow. Like in physiology, have you purchased any book till now for theoretical? What book? The book written by Dr. Pramanik. Okay. That's okay, that you are reading. But during the exam, we cannot mention about this any. We have to mention the names of standard textbook. We cannot mention the names of these books. We have to study from all. It is not possible in 9 to 10 months you have to complete the whole course. 3 subjects in the first year. Have you come to know of that? 3 subjects in the first year. First year means here we call it every prof. Prof, that is the prof is in short professional exam. First professional exam you will get more or less 1 year it is given, but it comes to 10 months, including all holidays and everything. 9 to 10 months you have to study 3 subjects. So it is not possible, humanly possible, actually humanly not possible to read standard textbooks and reference books for all subjects and then prepare for the exam. So you have to hold a book and for reference you will use the class notes or you will use the teachers will tell you some reference books or some reference materials you may use. But it is not suggested that you read standard textbook 4 or 5 books for every subject. It is not humanly possible. But during the exam, if the examiner is not happy with your answer, especially during the viva exam, you cannot quote I have read from this book or in the class it was told like this or something. You have to refer to some standard textbooks if you want to. That means one kind of challenge the examiner that I am correct. What I am speaking is correct. Okay. So this you should. So for that reason I am repeating what is given in different textbooks and how we will correlate it. Okay. So just in case of hemoglobin content, if anything comes in, just say 14 to 16 gram per deciliter. That is 1 deciliter is 100 milliliter. You may say 100 milliliter also. But 14 to 16 gram per deciliter and calculation of total hemoglobin content in the body is like this. Taking 5 to 6 liter of blood. And what we will discuss in the class, we will discuss from standard. So that the teachers will do it for you. They will discuss it from the standard textbooks. If you follow that, it is okay. But even if something you have read from the book but the examiner says no, this is not like this, don't argue with him or her during the, at least during the exam time. Just move on like saying maybe I am wrong, maybe I cannot recollect in that point of time, because as soon as you go try to establish yourself, you have to refer to standard textbooks, which is actually will be very difficult to follow in these 9 to 10 months. When you do study with one subject, you are doing after MBBS, you are doing MD or higher degree, so you are going for one subject. Then you may refer, you will get the time. For 3 years, you are doing one subject and you will get the time to go through those textbooks. But now, so this is just a suggestion. You may do according to your choice. But the thing is that whenever you refer to something, you have to tell. Whenever you try to establish something, you have to establish it according to the whatever are written in the. And they also vary. Different textbooks may write, there will be some difference of opinion between different textbooks. So I would suggest don't go into those. Whatever is told in the class and whatever book you follow, it is sufficient for you, at least for this level. Okay. Now we just told that function of hemoglobin is to transport oxygen and carbon dioxide. Mainly oxygen from the lungs to the tissues. So whatever function we relate to that, it is related to that. At the school level, we have also read that hemoglobin carries oxygen. Yes, it is the primary function. But due to this oxygenation and deoxygenation, it is also related to the metabolic, whatever metabolic changes erythrocytes are the red blood cells. Any metabolic changes in the erythrocytes, hemoglobin is responsible for that. So if you are asked to write the functions of hemoglobin, you may write like that. But main function is you have to write carriage of oxygen from lungs to, or not, better term is transport of oxygen from from lungs to tissues. Hemoglobin when hemoglobin is converted to myoglobin by chemical changes. Myoglobin has a similar structure, but it is not able to carry oxygen like hemoglobin does. So hemoglobin will carry oxygen, and in a way, oxygen and this is oxygenated. Hemoglobin is oxygenated, then it is deoxygenated. It is related to the metabolism of erythrocytes, and also that the erythrocytes. What is the lifespan of RBCs? More or less 120 days. So the senescent RBC, that is the RBCs which are dying. 120 is the life cycle, RBCs which are dying. So that initiation of the aging process, this RBCs degrading is due to this hemoglobin oxygenation and deoxygenation. So the RBCs which are not working, they will degrade. Okay. So that is how hemoglobin is acting. So hemoglobin, but the main function is always carriage, transport of oxygen from lungs to tissue, and transport of carbon dioxide from tissues back to the lungs. So for that there is, as we have calculated, there is 900, more or less 750 to 900 gram of hemoglobin in the body. And how hemoglobin is itself breaking down? What is CO? Carbon monoxide. So, under the action of an enzyme called hemoxygenase, hemoglobin is converted to biliverdin and carbon monoxide is released. This is the reaction. Hemoglobin is converted to bilirubin. Now we will study in the GI system that bilirubin. This is not a part of hemoglobin breakdown. Just what happens with bilirubin, it is converted to bilirubin and excreted through so at the GI system we started last Saturday. What was taught? So on Saturday, Dr. Shubham will be taking that class every Saturday. Okay. So in GI system, we will study in detail that how bilirubin, biliverdin, this biliary system, it will be discussed. So hemoglobin is converted to biliverdin. Biliverdin is ultimately converted to bilirubin and excreted to bile. So what is the enzyme? It is heme oxygenase. And you will learn a bit of it, these chemical things in biochemistry also. Previously in earlier days, physiology and biochemistry were included in the same subject. Now it has become separate. We have also studied last, it was more than 3 or 4 decades ago, physiology and biochemistry was taken into one subject during the MBBS, but now it is separate. So when is hemoglobin to biliverdin? This is easy. Hemoxygenase biliverdin. One byproduct is carbon monoxide. It has also functions in the human body. Nitric oxide, NO, carbon monoxide, everything is important in different physiological aspects in the human body. So see the importance of hemoglobin in the in the human body, that is it carries oxygen. See the importance of it. Oxygen is also present dissolved in the blood, that is in the plasma. What is the fluid content of the blood? Called fluid content. Blood has plasma and cells. This basic thing you know, blood is plasma and cellular component. Cellular component include this is not today's class, just for mentioning. This is more or less 45%. Okay, and this is 55%. So if this is 5 liter, this approximately comes to. So we take it almost 3 liter, almost 3 liter of plasma. So this fluid portion is called the plasma, and this when 5 unit. This is minus plasma minus. That's 5 unit is extracted from plasma. It is called serum. Basic process of blood clotting read in the school days. So that will also be taught, and you have to know it a bit of detail. The process of blood clotting. So there you will get the term fibrinogen. So plasma minus fibrinogen is serum. Okay. So that is not today's class. Just to mention, the oxygen is also dissolved in blood plasma to some extent. And the body fluid compartment. So there were three classes last week. No? These were the body fluid compartments taught. Body fluid compartments. So total body water content according to body weight. Yes. ECF, ICF. From there also we can calculate the volume of plasma. Okay. So total body water is 60% of total body weight. For 70 kg it's 42 liters. Then ECF, ICF 70 kg body weight, total body burden is 42 liters. ICF is 28 liters, that is 2/3 of this, and ECF is 40 liters. Out of this, plasma, this is ECF, this is ICF. Out of this, plasma is 1/4 of this, that is 3.5 liter, and interstitial fluid or tissue fluid is the rest 10.5, 3/4 of this. So you see, by this calculation, plasma is coming 3.5 liters. Here it is coming 2.75 liters, 5 liter, 55%. So this is, don't get worried with this, because we are always keeping on repeating this thing, that in this biology, physiology, human physiology, medicine, it is not like mathematics that 2 plus 2 will always be 4. Okay, so this is just some approximation. Human body plasma, the amount of plasma in my body will not be equal to another person's body. So it will vary between something like 3 liter, 3.2 liters, like that. So the basic aim is that the basic anatomy, the required, what is required, the functional for our living, that is maintained. So whatever functions are carried, whatever how one person is living with 3 liter of plasma, another with 3.3, does not vary, as long as they are leading a normal life without any disease. Okay, normal life means without any disease. So that is not. So this is not today's class, but just I mentioned it that, see, by this calculation it is coming 3.5 liter, and by the calculation from blood, how much is plasma, how much it says, it is coming 2.75 liter, but nothing to worry about that. Okay. So 3 to 3.5 liter is the amount of plasma in the human body. Say 60 kg person will have less amount of plasma, but that does not mean that he or she is diseased. It will vary according to the body weight. Just from simple calculation, 60 kg is 36 liter of water. So accordingly it will vary, 36 liter. So ECF will be, ICF will be 3/4 of that, 27 and 9, and out of 9, 1/4. Okay. So the amount of plasma will decrease, but that will not hamper the basic life processes. Okay. So no need to get worried about that. So in both ways plasma can be calculated, and whatever you get, you will say 3 to 3.5 liters. So what we are telling, dissolved plasma is only, dissolved hemoglobin is only this. Sorry, I'm sorry. So this is very less amount of oxygen is stored in the plasma, and maybe the whole blood is 5 liter, out of that is 3 liter is plasma, but still you see it does not meet the oxygen requirement, because oxygen requirement is much higher. This will come to almost, by calculation we can take this out, this will come to almost 15 milliliter of O2 is delivered to tissues only if we take into account the dissolved oxygen. So hemoglobin will carry 98% of the oxygen. Okay, so only the dissolved oxygen, the point is that dissolved oxygen is not sufficient to carry out the body. So if hemoglobin is lessened, so even when there is severe anemia, also there is respiratory trouble. What is this? Because the tissues are not getting enough oxygen, and the body is trying to compensate by hypertension. So there will be respiratory when hemoglobin is reduced in severe anemia. So dissolved oxygen is not sufficient to carry out the oxygenation of the tissues. Hemoglobin is required. That is the importance of hemoglobin. Hemoglobin how much hemoglobin it carries, we will come to that in the next class. How much oxygen is carried by hemoglobin? Just to know the figure, 1.34 gram every 1.34 ml every gram. Okay, we will come to in the next class. So hemoglobin basic structure is protoporphyrin ring, pyrrole rings forming the protoporphyrin ring, and at the center of that is iron. Ferric form cannot carry oxygen, ferrous form can carry oxygen, so it is important to mention in the ferrous form. And by chemical changes, hemoglobin is converted to myoglobin is also an important molecule in the body. It is required in muscles, but it is not sufficient. It is not possible to carry oxygen with myoglobin. So it has to be remain in the heme form to carry oxygen to the tissues. So the main function we are repeating it in every sentence, that is hemoglobin carries oxygen, and so it is also related to the metabolism of erythrocytes and also the erythrocytes dying down. The erythrocytes which are dying, which are aging and dying. So oxygenation of hemoglobin is initiating the aging, those erythrocytes which are to be now dying down, that is called so. But the primary thing that it transports oxygen to tissues from the lungs and carbon dioxide from the lungs to the tissues and carbon dioxide from the tissues to the lungs. And when you speak of hemoglobin content, it is 14 to 16 gram per deciliter or 100 ml, and total content is, we can calculate from that only. If you notice, maybe 15, taking 14 to 16, average is 15, so 15 into 10 for converting into liter, 1 liter 15 into 10, and then multiply it by 5. 750 to 900 gram is the hemoglobin content. And it will be, when hemoglobin is breaking down, what is happening? What is forming? The enzyme is hemoxygenase. The formation is biliverdin. Biliverdin will be, that is not a part of hemoglobin breakdown. Biliverdin will be converted to bilirubin and excreted to fluid. Byproduct of heme to biliverdin is carbon monoxide. Okay, now just speaking of some, what is the most of the hemoglobin in the adult human body is. We'll read the variants of hemoglobin in the next class. Just one variant is hemoglobin A. What is? So the globin chain, should mention the structure. Those MPV, methyl propionyl or vinyl structure. So the structure and the bonding, the chemical bonding there, it will vary in the different forms of hemoglobin. So the globin chains are named as alpha, beta, gamma, delta. These names are given to the globin chains, and accordingly the variants of hemoglobin are formed. If there is ferrous form in the middle, then only similar structure, chlorophyll, that will contain magnesium. But here hemoglobin, there is a ferrous form, iron, that is. So with the varying structure, with the globin structure varying, the different forms of hemoglobin we will get. So hemoglobin A is the most abundant in the adult human body. So that contains, so those 4 rings, that contains 2 alpha and 2 beta. It is written like this. It is written as a subscript. Subscript means you write that number after the letter. Write that number and below. Superscript is above. Like we write to the power. 10 to the power 2 is 100. That is, when we write 2 above that, it may not be a letter also. 10 to the power 2 both are numbers. So superscript is, after writing this, we are writing it above. This is called subscript. So we write it as subscript of alpha to beta 2. That means there are 2 alpha chains and 2 beta chains. That is hemoglobin A. We study the other variants. Oh, one thing I am sorry, I forgot. Hemoglobin, one function. All is related to oxygenation and deoxygenation of hemoglobin. One function, genetic resistance to malaria. We read about sickle cell anemia in the next class. Genetic resistance to malaria. Function of hemoglobin. Also, that it has implications in genetic resistance to malaria. The disease malaria, MALARIA. That you may include in the function. But primary function and everything, what is other functions we are relating it to the oxygenation of hemoglobin, transport of oxygen from lungs to tissue. So when we get hemoglobin variants, we will study hemoglobin variants. In the next class, we will study about it. Hemoglobin A is 2 alpha chains and 2 beta chains. Okay. So almost 90% of the, more than 90% at least of the adult hemoglobin in the adult human beings, all of us here, is hemoglobin A unless there is a either congenital defect means the defect by birth, congenital defect or structural defect due to something else, some disease process. So most of the hemoglobin in the body is hemoglobin A, that is 2 alpha chains and 2 beta chains. Okay. Heme plus globin chains, 2 alpha chains, 2 beta chains, alpha 2, likewise there may be alpha 2, gamma 2, okay, and others, but this is hemoglobin A, this is the adult hemoglobin. So, structure, content, synthesis in the red bone marrow, functions, and just to mention, we following the other part of the hemoglobin in the next class, the variants of hemoglobin, we study about that. And synthesis and also breakdown, we have told that just hemoglobin to biliverdin and then converted to bilirubin and excreta.